Hello and welcome to the Formula Student Online podcast. It's the 4th edition. I'm Giles Cosgrove and you join me here in the lab of UH Racing. You'll notice it is just me. There's an empty passenger seat. Cheryl is away sim racing, so unfortunately you're stuck with me. But you are stuck with me for a fantastic edition because we are here at the University of Hertfordshire. We've got the lowdown on the team, on their car and on their fantastic new facilities here at the Spectra building. It's all to come, so stick around. So we are at the Uni of Hertfordshire in the lab of their Formula Student team. Guys, welcome to the Formula Student Online podcast. Pleasure to be here. I'm going to start on my left. Can we just go around and introduce yourselves and what your role is in the team?
Hello, I'm Harry Smale and I'm the head of statics.
Hi there, I'm Kieran Huber. I'm now a faculty advisor at the University of Hertfordshire.
Hi, I'm Robbie. I'm a first year student. I'm still getting to know the team and trying to figure myself way around in the team, so still learning.
I'm Jan, I'm a level 6 student, just one of the member in the chassis department.
And I'm Matthew Brown, I'm head of aerodynamics for the team.
Fantastic stuff. So Hertfordshire has a bit of a precedent within Formula Student circles, being the home of Monty. This is where Monty went to university back in the day. Back in his day, the powertrain was internal combustion. Things have moved on and you are now an electric powertrain. What is the difference between running an electric powertrain and running an internal combustion powertrain as far as the Formula Student team is concerned?
Well, I'm certainly a lot louder than the other.
Yeah, fair enough.
No, I think Harry's hit the nail on the head there. It's been a big challenge going from internal combustion to electric vehicle, not only on the technical side, and bringing everyone's knowledge of how an electric powertrain works up, but also on the procedural side. How are we going to assemble this thing? Are we going to assemble this thing safely? As we found out through various iterations of our working processes. We've now managed to hammer that out and we have an assembled accumulator, but then we have far more issues in terms of calibration and working things through with signals that you wouldn't necessarily have on an internal combustion car. So there are a plethora of challenges that we face, but it is probably akin to what a new Formula Student team who are doing an internal combustion car would face, because this is an entirely new vehicle philosophy, entirely new vehicle concept for us. It's exactly the same as a fresh team coming into an internal combustion car. I remember when I was a first year student and the existing team lead said to me, "Could you design me a Formula Student car?" On my first day I was like, no. And it's very much the same thing. We look at it as a fresh challenge each year. We look at the issues that we face and we figure out a plan to go through them. So both have benefits and drawbacks, but we're planning ahead with the EV route.
You mentioned a couple of engineering terms there, like the accumulator, and those involved in Formula Student with electric powertrains will be all too familiar with that, but potentially outside of that arena, there might be a few questions. I imagine most people are familiar with how an internal combustion engine works, but with an EV powertrain, it's a bit different. Could you talk us through the general concept of how an EV powertrain works?
Sure. So the term I used, accumulator, purely means battery pack, just a Formula Student term for it. Our battery pack outputs a direct current voltage, which then gets sent through to our inverters, which takes our signal from a direct current signal into an alternating current signal. And then this gets sent out to each of our, in our case, 4 motors, as we have in individual wheel drive in-hub motors. This is common across all Formula Student team, the change from a DC voltage to an AC voltage, but some teams run just one motor at rear-wheel drive, which is very similar to how a rear-wheel drive combustion car works. So there are definitely various similarities between.
You mentioned some of the challenges. You said it was a challenging evolution to make, going from IC to EV. what are the standout challenges? What are some that you can name off the top of your head that stick in the mind?
Good question. I think one of our biggest challenges was figuring out how we're going to assemble a battery pack safely. How do I say it? Internal combustion, just like you were mentioning, pretty much everyone knows how one works, how to assemble one. It's very common knowledge. Electric battery packs are somewhat different in that they're new technology for vehicular purposes. So figuring out how to then go about and say, right, we're going to do this safely, but we're also going to do it in a way that allows our students to learn was very difficult, because you look at professional motorsport teams, Formula E teams, for example, when they're assembling their battery pack, well, actually, it's not necessarily them who assembles it, it's an entirely different entity. Here, we do the entire thing. We go through the whole specification, we go through the design, we then go through the assembly, and then we go through the testing. So it's a much more involved process that in industry gets managed at different points by different people. And building up the knowledge base of the team for something like this is a big challenge. So, yeah.
Not only is the challenge with the powertrain, it's also with the general design of the car and the making of the car as well. You were talking to me earlier before we hit record about some interesting problems you were having with the welding rig for the chassis. Would you care to explain those?
Yes, so for this year we decided to do something new with how we jig the chassis. So in order to improve our tolerances and the overall quality of the welds, we have implemented a full chassis jig. So Jan can explain a bit more about how we designed that.
Yeah, so basically it's a wooden jig. We just have two spines in the middle, which is with thicker wood, MDF wood, 9mm, just to hold everything together. And then we got some different arms at different angles poking out from the spine to hold all the tubes together. Since this is the first year doing this, we got quite a few issues because the jig is designed to the cab in the chassis, so basically a perfect chassis. But when we're manufacturing, so we outsource the roll hoops to be manufactured. They are not as what we want compared to CAD. So we either have to do something to the roll hoops, or we cut away a few bits in the chassis jig just to make things fit. And other things we've just learned is, because we got a spine in the middle, the welder cannot really see what's inside of chassis when he's welding. So what we do this year is, after we seam weld the outside of chassis, we have to destroy the jig just so he can weld the inside. And one more thing is the arms is not surprisingly, most of the arms is in his way while he's welding, because when we cut it, the arms are really close to the joints, so it's quite difficult for him, the welder, to maneuver.
Because the jig acts as essentially a cradle to hold the parts in before you actually put them into place for welding. So it gives you an approximation of what it would look like when fully assembled, and then you can make the final joints with the weld. So those arms you're talking about, they're holding the parts in place very close to exactly where the welder was going to weld.
Yes, so he found it difficult to maneuver around the tubes, so things we need to change for next year.
Well, it's all a learning experience. That's what FS is all about. And you're designing a car year on year, iteratively. What's been the fundamental driving factors in the design of your car this year?
Well, I've actually made it a point to, I've written down the team goals, the whiteboard over there, display the team goals on the whiteboard so everybody in the lab can see it. So our team goals are keeping it dynamically in all events with individual drive electric car, complete 150 kilometers of dynamic testing prior to competition, FSUK this being, improve the dynamic performance through data-driven decisions, and to reach the finals of all static events at FSUK. Now, the reason why I wrote them up there is because if you are in the lab doing a task, you can look up at the whiteboard. If what you're doing in the lab relates to those goals, then pursue with it. If it doesn't, then do something else that does.
Right. So very efficient use of time.
Certainly, yeah. I think the big driving force this year has to be getting the car prepared for dynamic testing. I think that's one of the biggest things we're missing right now, because if we are able to test dynamically, I do think it will improve almost every aspect of our operation. Unfortunately, we have not had a running car since 2019. The development of the all-wheel drive electric concept has been very difficult, fraught with a lot of challenges, but with each year we learn something new. And this year, that learning experience finally crescendoed with us being able to turn motors on our own power for the first time since 2010, which is a massive, massive achievement for this team. Quick shout out to Tom Johnson, who made it possible. Thank you very much, Tom. So now even then, we've also ran into more issues regarding that. We're still tweaking for instance, the power delivery, trying to get the pedal, the inputs from the pedal to communicate properly with the motors, trying to get them to all.
Because that's the problem that you've got, is it's not just communicating from one pedal to one rear motor or one engine, it's all the motors in each wheel that you're having to communicate with. Are you doing any sort of torque vectoring with that?
We have torque mapping.
Right.
So it's like, it is sort of similar to torque vectoring in the sense that a certain torque load will be applied on the motor under a certain dynamic load on the upright. But instead of computing it dynamically, which if we were to do that, then the system would have to be so fast that it wouldn't be reactive. It'd have to be predictive, which I just don't think we have quite the knowledge base to develop that at the moment. So instead, what we have is a lookup table essentially of all these different loading cases on each of the corners. And once a loading case is detected, once it's registered on the corner, then it can go to that lookup table, look up the specific torque that is required, and then allocate it to that motor.
You vary the percentage over the course of the front wheels and the rear wheels, depending on what the drive is and what event you're competing in.
Yes.
I love this stuff. It's so cool. This is sick. So, I mean, I love this very clearly. If someone's considering getting involved in Formula Student, whether they are doing their A-levels at the moment, considering coming to university, looking at what universities have got good Formula Student teams, or maybe they're already at university and they just have caught wind of Formula Student as a concept, what would you guys say to them about getting involved in Formula Student?
I've level 4, first year. I did a lot of research trying to come here. I mean, I've come all the way from home in South Africa, so I had to do a lot of research to try and figure out where do I want to go. And I had more time, thankfully. The timelines for our education is a bit different. We finish in December, you guys start in September. So I had time to think about it and really put my mind to figure out where I wanted to go. And, you know, I've always loved cars, I've always loved racing. So found out there's this thing called Formula Student and immediately piqued my interest. So looking more into it, looked into the teams, looked at the universities. Then I came through to Herts and I saw have a new building coming in, got a great team with great heritage, and it just seemed like the right place to go to. And I've been so happy here since. I mean, I've really been able to learn so much and do many things that I don't think I would have been able to do anywhere else. It's been great.
It's a glowing review for Formula Student. I'd like to quote you on that in the brochure. Is there a Formula Student event in South Africa?
We had a Formula Student team many years ago.
Right.
I'm not sure if they're there anymore. When I looked through, it was difficult to find anything, so I was reluctant. But I always knew I wanted to study internationally, so come to the home of motorsport, UK.
South Africa, if you're watching, get Formula Student. It's worth it, clearly. And evidence right here. We've got first-hand account of why it's worth doing. Anybody else want to throw in?
I think, obviously, your degree teaches you so much, but FS bridges the gap between industry and what we're learning in the theory. I think, you know, you don't get to lay up carbon fiber panels in your class, where you do in FS. So that's experience that you just don't get doing your normal degree. And that's what, when you come to apply for jobs, that's what sets you apart from people you're competing for the same role with. And that's stuff that industry looks for and sets you apart. Yeah.
I think there's something that Howard, our other, my now colleague, formerly mentor, very strange, Howard once said to me as a student was that there are very, very few places in the world where you get to be involved in a motorsport context of conceptualization, design, simulation, build, testing, and then competing dynamically and statically with a car that's got all of your fingerprints on it. And it really is a rewarding process. You go from the start of the year in August, September, all the way through to July. In some cases, if you go to international competitions, you're going all the way through to August. And you get this fascinating breadth of opportunity. And that's just on the engineering side. But we obviously, through our static events at Formula Student, we have the business plan, the cost of manufacturing event, which are two slightly different disciplines that allow for students who may not necessarily be on an engineering course but still have a great passion for motorsport to get involved and really make a difference to the team.
So what impact has being involved in Formula Student had on all of you professionally and personally? I mean, you haven't left. Couldn't you had opportunity to, and then Stockholm Syndrome took hold?
Pretty much. Our friends at ECU Racing, who we hosted last year, fantastic team, lovely people. I was speaking to their faculty advisors, Kev and Fernando. They described it as post-FS life, and I give the inverted commas because it's very much you're still involved with Formula Student. And when I graduated, I wasn't necessarily expecting to stay involved with Formula Student, but the opportunity to be not only involved with Formula Student here, because I still do that as a technical scrutineer, but be able to teach and help students who are passionate about motorsport engineering learn about that very subject is something that really appealed to me. So I guess you can say it's left a massive imprint on me. I led the team in my final year. I'd say against all odds, against a lot of odds, we did fantastically well, and I'm very proud of how what we did as a team, but also how each individual member of the team grew over the course of the year. So it's a really, really rewarding process for me to see that not only as a team member, but also now on the faculty side, and I get to see that with all of these guys.
How have you all found it? How has it been impacting you personally and professionally?
I mean, first year I didn't expect to do the things that I'm doing now. I mean, in our course, you get a lot of touch on briefly because it is first year. But Formula Students allowed me to learn more complex things very quickly. Analysis, FEAs, to doing CAD models and optimizing things. So those are things that I wouldn't have experienced yet in my course. They're more next year, third year. And I've been able to do it already now, so I'm just that much more prepared for next year.
So you're going to be the guy everyone's copying their homework on. It's already happening. It's already happening. Fully, the effort, they're just absolutely fantastic stuff. And you've been involved since your first year.
Yeah.
Coming up to the end of your degree now.
Yeah, I've been here literally my entire career, if you can call it that, at university, and I think in every single one of those years, Formula Student was always my favourite thing to do, and it's not even a part of a course. It's like the things you will learn here, you will carry with you for the rest of your life, not just technical skills, but also the interpersonal skills, the ability to talk to other people, to transfer knowledge, to communicate, interdepartmentally, to kind of... The thing I loved most about Formula Students was like every morning I would walk in and I would see the car in front of me in the old lab, and I would think to myself, about 6 to 8 months ago, that did not exist. That was an object that was not present in the world. And from imagining it in our heads to putting it on a computer screen to then manufacturing it to then bring it all together, just what that object represents. It represents countless hours. It represents redesigns. It represents banter over, another bracket failing again, or, not being able to find a 10 mil. Like, there's so much just kind of...
all been that.
There's just so much, there's so much kind of life in it. It reflects so much human effort, and, you then realise that you've been a part of that human effort, and it's just, there's no other way I can describe that feeling other than it is one of the best feelings in the world, and I want to feel it as often as possible in industry.
There's no better way to finish that. I couldn't think of a better way to finish that. Guys, it's been an absolute pleasure having you on the podcast. Thank you ever so much for joining us.
Thank you very much.
Yes, thank you. Cheers.